So this is locate the, well, just as simple as that. Let's say centroids of the area. And what area I'm talking about? Here is the area. Basically, the area is, if I put the coordinate system there, I can draw this area like this. I can just say this is X, this is Y, this is X, this is Y, and I'm going to try to draw it as nice as I could. There we go. Almost there at the end. Just got straight line from here. This is the area, basically. This is the area we're looking at. All right. We know that, oh, this is a vertical line. The equation for this line is y is equal to x squared, right? And what information, what else you need? You need to know what is this height. So this height is, I can write the proper color. This height is 1 meter. I'll put it there. This height, this length is also 1 meter. So this is 1 meter. This is 1 meter. And we're trying to find the centroid of this area, like X and Y coordinates, where the center of area is for this specific area, right? That means we want to calculate these integrals. Remember, for centroids of an area, we have X is equal to integral X dA over integral dA, and Y is integral Y dA over integral dA, right? So let's just calculate this. Let's start with X. Right? X is integral X dA over integral dA. Right. Now, that integral, although we put it like one integral, but in reality, it's a double integral, right? It's an integral over an area. So we're dealing with a double integral. And what we want to do, we want to convert this double integral into a simple integral that we can calculate, right? A double integral is the integral that we take over an area. So both of these in reality should be written like this, right? Integral and integral, because it's an integral over an area. The integral we're comfortable with is the simple integral that we calculate, like dx, dy, or whatever integral is, right? That we can calculate. This integral over area, we have to convert that into a simple integral that we can actually calculate, right? So see, how do we do that? For area, this is double integral. If it was a volume, like when you're trying to find the center of a volume like this is basically is a triple integral, right? It's like this, 2, 3 dv. So we have an integral over a volume. Right. Now this is a integral over an area. So what we want to do is that we want to convert it into an integral that we can calculate. How do we do that? We have to find a way to get rid of that dA, right? So we have to find an element area, right? Define an element, specific element, and convert that dA into something we can calculate the integral for, right? How do I do that? Well, I say, well, if this is some random place, let's say here, I take this as a differential element, right? And this element is located at somewhere like x, right? Whatever x is in this direction. And the tip right here is y. So this is also y, the height is y. And y and x are related, right? At this point, we know that y is equal to x squared at any point on this black line there, because that's the equation for the line. So y is equal to x squared. We know that y and x are related. So what we are doing is basically we say, and this element is a small element. It has the width of dx. So what we get out of this is, well, we'll say dA, well, if it's dx, so the area for this element is dA, right? dx times y. So dA is y dx. Right, that's the area. So the height is y, the width is dx, the area of the element dA is y dx. Now we know what y is for any given, because we're looking at this height. Y is x squared, so it becomes x squared dx, and that's all we wanted. So if you go back to our integral, that double integral becomes integral from well, x y dx, right? From what is changing? X is changing. X is changing from 0 to 1. That's dx. The denominator dA, well, dA we said is y dx, right? I just put it here. And x is changing from 0 to 1. So we take that element, using that element, we're going from a double integral to simple integral that we can calculate. Now, here we can calculate the integral. We want to find dx, the integral over x. We know we have y there. We have to get rid of that y. Well, we know y is equal to x squared. So this becomes integral from 0 to 1, x cubed dx over integral from 0 to 1, y is x squared dx. Right? So that becomes, if you take that integral, I think you'll have to put x bar here. Take that integral, you'll get 1 over 4 x to 3 from 0 to 1 over 1 over 3, this should be x to 4, right? Over 1 to 3, x to 3 from 0 to 1. That becomes 0.25. This becomes 1 over 3, which gives x bar as, if you do that calculation, you should get, well, 3 times 0.25, so it becomes 0.75. This is your x bar. That is the x coordinate of the center of the area for this area. I want to find bar, like y coordinate of the center of the area, right? We'll say double integral. I can just write it the way we wrote it. Integral. But just keep in mind that it's a double integral, right? This integral, we said y d. Let's just go back to the equation we had. So I'm not making this up. We found this here, right? Here. Y bar is integral y dA over integral dA. Right? So integral y dA over integral dA. Same story. Now we are trying to find y bar. So we have to change the element, right? Whatever we want to find out, we have to take the element in that direction. So now looking at the same area, this x, remember the whole story is that because I want to get rid of this double integral and make it to a simple integral I can calculate. So to draw it as similar to the other one as possible. So I'm just drawing this again. This is the area, right, that we're trying to find the y coordinates for it now. This is 1 meter in this direction. So 1 meter in this direction. And this line there is y is equal to x squared. right? Now, the new element I take to calculate this integral should be in a way that y is changing, because I'm trying to find y bar. So I'm going to take the element this way. This element right there. That would be my dA. Right? This has the area of dA. Now, what is it's this direction. Right? What is its height, right? Because we want to find the area. So height times width. Right? Let's go with width, right? In this direction. That one is, if this is x, since I defined this as x, if this is x, then this, if this is x, this would be 1 minus x, right? Because the whole thing is 1. If this part is x, that part is 1 minus x. And this is also height. So the height would be just y. So now the area for this is dA is equal to, well, the height 1 minus x, right? Dy, because this is dy. The width here is, the height here is dy, right? You want to find dA, which is the area of the element. The whole thing is 1. We took x from origin from the left, which means the height of this element is 1 minus x. The width of this element in this direction, the height in this direction is dy. It's the element, this is this direction. We want to calculate the integral. So that's the changing direction. Now we plug in into the general form of the equation you have, right? So you have y. Now your dA is 1 minus x dy over, remember, now we go from double integral to a simple integral. Integral 1 minus x dy. What is the range? Whatever the y is changing, because now we're looking at dy. So y change, dy goes from y, whatever y is at the beginning, to whatever y is at the end, from 0 to 1. 0 to 1, 0 to 1. Just remember, this 0 to 1 is different from previous 0 to 1. Previous in x, when we calculate x bar, 0 to 1 was how x changes. This one is how y changes. But the example here, x and y both change from 0 to 1. Now, this is the integral with respect to y, right, over y. So we have to get rid of that x there to be able to calculate this integral. Right? Now, what is x? Well, we know what x is. We are given the relationship between x and y. If we know y is equal to x squared, right, that means x is equal to square root of y, or y over y raised to 1 over 2. Right, so it's the square root of y. If you plug that in here, you will get 0 to 1 y. Let's multiply that, minus y 1 plus 1 over 2, so 3 over 2, right, dy divided by this. You can just separate things. You can just say integral from 0 to 1 dy minus integral from 0 to 1 x dy. X is y over 2 raised to 1 over 2 dy. Right? Then your job is to calculate this integral now. That's something that's relatively straightforward. The integral for the first one becomes 1 over 2 y squared, right? I'm looking at numerator, and then it becomes 2 over 5 y to 3 over 2, right? And this whole thing evaluated from 0 to 1 over here is y minus 2 over 3 y to 3 over 2 evaluated from 0 to 1. If you do this math, Well, becomes half minus 0.4, becomes 0.1, and denominator becomes 1 minus 2/3, so it's going to be 1/3. This will give you y bar as 0.3. So if xy coordinate is placed at where it's placed right now, the center of area for this, or centroid for this area, is going to be somewhere. I don't want to draw this again, just very quickly. So the center of area, x and y, I end up drawing, huh? Center of area would be at x bar, which is, was it 0.75, so it's somewhere here, maybe. So the center of area is at x bar and y bar, right? That's where the center of area is.